Hi, and welcome to this applied question on benzene combustion using gas moles and grams per decimeter cubed data. So the question asks us 1 gram of benzene burns completely in oxygen to form 1.846 decimeter cubed of carbon dioxide at room temperature and pressure and 0.692 grams of water. It gives us the density of benzene vapor at room temperature and pressure, being 3.25 grams per decimeter cubed. It's asked us to use this data to show the molecular formula of benzene is C6H6. So what initially might look like quite a confusing question can be broken down into its component parts by processing each piece of data separately. So let's process the 1 gram of benzene. So if we do mass over molar mass, it's 1 gram over 78 grams per mole, which gives us 0.012825. I'm going to use this as a reference point later on, because we were not told in the question that benzene is 78 grams per mole. And like it says in the highlighted part, it says use these data. So I'll come back to this 0.0128205 a bit later on. It says it burns completely in oxygen. So another quick reference point would be to construct an equation. And we can see the ratio of benzene to carbon dioxide to water. So 1.846 decimeters cubed of carbon dioxide at room temperature and pressure means you use V equals 24N. So if we rearrange that, we can work out the number of moles of carbon dioxide as 0.076916. If we take the mass of water and we just do moles as mass over molar mass, we can get 0.0384 moles. Now, it gives us the density of benzene vapor, so we have to use that somehow. So if we assume benzene as a gas, i.e. benzene vapor, again, V over 24. If we do data equals mass, or density equals mass over volume, we can work out the volume of benzene vapor. So therefore, that's 0.307692. So to get that, I just divided 1 gram over 3.25 grams per decimeter cubed. So now I can stick that into N equals the number of decimeters cubed over 24, and that gives me 0.012825. Now I've used the data this time to get that number, but we can compare that to the one from before, and it's exactly the same number. So we know that we're in the right place. So if we go back to the question and take all this working, we can now use it to prove that the molecular formula is C6H6. So if we ignore the oxygen in the equation and just look at the benzene, the carbon dioxide, and the water, because oxygen is obviously going to be in excess because it tells us that it burns completely in oxygen. The only way that could work is if there is excess oxygen provided. So remembering that the benzene was 0.0128205 moles and the carbon dioxide was 0.076916, a quick ratio check will show us that's a 1:6 ratio. So because there's one atom of carbon in every carbon dioxide molecule, therefore 1 mole of benzene gives 6 moles of CO2. So therefore there must be 6 carbon atoms in the benzene molecule. Doing the same thing with water, but remembering that water contains 2 hydrogens, so therefore there's 0.0768 moles of hydrogen atoms. That's not exactly a million miles away from 0.076916. So if we imagine benzene to be C6Hy, the number of moles of benzene to CO2 is 1:6, so X equals 6 for carbon. And the number of moles of benzene to the number of moles of hydrogen atoms is also 1:6, so Y equals 6 as well. So that means benzene has a molecular formula of C6H6. Okay, I hope this has been a useful short clip taking you through how you use some rather disparate data that might not be immediately obvious. And by taking each bit in turn, you can arrive at a place where you can use all the numbers to get your molecular formula. Okay, thanks for listening. Until next time, see you soon.